Chapter D, powers of x. Now we have, in the previous chapter, used our formula for the derivative, our general formula, as the limit as delta x goes to 0, f of x plus delta x minus f of x over delta x. So this is our definition where the numerator is the rise and the denominator is the run. And we discussed that in our class C, the derivative. Back in that class, we did the following cases. Let's go ahead and list the function here and its derivative. If we have a constant function, the slope is 0. If the function is x, we found the slope to be 1. These are our results from the previous chapter. X squared, 2x, mx, slope m, mx plus b, slope m, and ax squared, 2ax. These are the results. Now, in this chapter, we're going to look at the general case. You see, you can think of this c as x to the 0th power. This is x to the 1st power. This is x squared. And what we are interested in would be going from this one to x to the nth power. And that would include all these where you can let n equal 0, n equal 1, for example, etc. But before we do that, I like to do the function x cubed. Now, you might remember from algebra a plus b cubed, if that is. Let's go ahead and review that. That would be a plus b times a plus b times a plus b squared. Now, a plus b squared would be, you would square the a first, a squared. Then you would add 2ab, and then you would add b squared. Then to work this out, you would have here a times a squared is a cubed. A times 2ab is 2a squared b. Then a times b squared is a b squared. There are the three terms. A times a squared, a cubed, a times 2ab, 2a squared b, a times b squared, ab squared. Then when we bring the b in, we have ba squared. That would be one of these. I'll put the a squared first. Then b times 2ab is 2ab squared. 2ab squared. And then b times b squared is b cubed. And then we need to add these up. We would have a cubed plus 3a squared b plus 3ab squared plus b cubed. Now we're going to need this because when we put the function value x plus delta x, we're going to need that cubed. So we're looking for our derivative here. the limit as delta x goes to 0 of x plus delta x cubed, because that's our function. We're doing the function x cubed. So we need x plus delta x cubed, and then we're going to have to subtract from this x cubed, and then all of that is going to go over delta x. That looks kind of weird. Let's go ahead and write that out again. This would be the limit delta x go to 0. I would have x plus delta x cubed minus x cubed over delta x. So now it looks clear. What we want first is, this is f of x plus delta x, so it's x plus delta x cubed, and this is minus f of x, and that gets you the subtracting of x cubed and divide by the delta x. So this is what we're interested in doing. And that's nothing more than putting the f of x with the x plus delta x, the minus sign, the f of x, remember f of x is x cubed here, and divide by delta x. So now we're going to use this idea here where the x is a and the delta x is b. So if we do that, we would have the limit as delta x goes to 0, and we're going to have here in the numerator going to be x cubed plus 3 x squared delta x plus 3. We're just making the comparison that there's your 3, your a squared is, here's your a, so it'd be x squared, and delta x is your b. So now we have a 3 again, and we have an a, which is your x, and b is delta x, and that one's going to be squared. And then the last one is the b, which is delta x cubed. Then we subtract x cubed, and all this gets divided by delta x. The miracle occurs again. Delta x goes away in the denominator. That's very important. There we go. The x squareds go, and now there's a delta x, at least one delta x factor and another delta x factor in there, so now we can divide by the delta x. We haven't taken delta x to 0 yet, so we're not dividing by 0. So this is going to be the limit as delta x goes to 0 eventually. And this is going to be 3x squared. That delta x is going to cancel. And then we're going to have a 3x, and here delta x squared over delta x is going to leave one delta x factor. Here you have delta x cubed. There's 3 factors. You're going to divide by 1. So that's going to reduce this one to 2 factors. And that, see, all of that is what we have to figure out. We already divided by the delta x. So, like, what is this? All right. Well, when the delta x goes to 0, this one is going to head to 0. This one's going to head to 0, and you're going to be left with 3x squared. That's the answer. Now this is interesting here, that the derivative and x squared, you pull down that 2 and then reduce the power of x from having to square the 1. And this is doing a similar thing. You take, for example, you're looking at x cubed. You pull the 3 down and then reduce the power of x by 1, and you get your 3x squared. And that's like working for all these. You pull the power of x down 0, well, you get 0. You pull this one down, you get a 1, and then x to the 0 is 1. You pull the 2 down, and you knock this down 1 unit, you get x. So this seems to be working. It suggests that maybe this general case might be n times x to the n minus 1. That you pull the n down, and then you knock the x power down by 1. Now, I would like to show that that is indeed going to be the case by doing the general case next. But before we do that, let's go ahead and show this cool picture where we have x cubed, a plot of x cubed. Notice that when x is negative, x cubed is negative because there's 3 minus signs in there. And then it's 0. When x is 0, y is 0. And then here you get positive values. So the slope here is positive and steep. And then it's going to get less and less and go to 0. So here, when x is less than 0, so here's the big slope. And then it's getting less and less. And when you get to 0, it's 0. But then it starts getting positive again on the other side. So it's interesting that 3x squared, see, is doing that trick. Positive slope, decreasing to 0, and then positive slope increasing again. So positive slope, decreasing to 0, and then gaining on the other side. Now to do the general case where f of x is equal to x to the n, we're going to need f of x plus delta x, which is going to be x plus delta x to the nth power. So we're going to write down here for the derivative, it's the limit delta x going to 0 of this result up here, x plus delta x to the nth power, and then subtract x to the n and divide by delta x. So that's what we're interested here. That's what we're interested here. So there's the f of x plus delta x, which is up here. Subtract the f of x, which is there, that's your rise, and divide by delta x. So we need to work this out. X plus delta x to the nth power. Well, that's going to be x plus delta x, x plus delta x, x plus delta x, and you're going to keep doing this, x plus delta x, where that here, they're n factors. And here we're considering n to be a number like 1, 2, 3, 4, 5, 6, 7, 8. Right? We're restricting that to a positive number, or it could be 0. All right, because then if you have n is 0, you have this case. If n is 0, you get 1 minus 1. You're going to get essentially, for the constant, the derivative is going to be 0. All right, so just want to emphasize n is equal to 0, 1, 2, 3, all the way up. All right, so when you multiply this out, the first term is going to be, all the x's are going to be multiplied, and there's n of them. So the first term is going to be x to the n. After picking x from every one, there's only one way to do that, I'm going to now pick one delta x, and the rest are going to be x's. So that's going to give me, I'm going to leave this blank for now, because I'm going to just put down what I'm going to have. I'm going to have n minus 1, see, x, n minus 1 factors of x, and I'm going to have 1 delta x factor. So the first term here is you multiply by all the x's. Only one way to do that. You pick x from each one. The next one, I'm going to pick a delta x, and then the rest are going to be x's. So that'll be x to the n minus 1. And how many ways can I pick delta x? Well, there's n factors, so there's n ways. Now the next term here is going to have some number in front, and it's going to be x to the n minus 2, and delta x is going to be squared. And then you keep increasing delta x factors, numbers of factors, and this decreases. So the last one is easy to figure out. The last one would be all delta x's multiplying together. So really what I'm interested in is this one, the second one, and knowing that all the others have to have at least one delta x factor. So therefore, for the derivative here, we'll have the limit as delta x goes to 0. We're going to have x to the n plus n delta x. And then there's going to be terms in here that have delta x squared, delta x cubed, delta x all the way out until you get delta x to the nth power. Then we're going to subtract x to the n and divide by delta x. So the key here is that you're going to have a cancellation, as we've had before, of the function, in this case x to the n. And then here there'll be one delta x here, but then it'll be delta x squared, delta x cubed, delta x, fourth power, all the way up till you get to delta x to the n. So here I'm going to have, if I look at this term here, this is going to give me n x n minus 1, and all the other terms here will have at least one delta x in it. So when I take the limit as delta x goes to 0, all those other terms are going to go away, and I'm going to be left with n x to the n minus 1, which is kind of what I was guessing the formula might be, looking at the pattern we saw earlier. Before I leave this discussion, where we have looked at x to the n and shown that the derivative is given by bringing the n down, then writing the x down, and then have an n minus 1 for the exponent, knocking the exponent down by 1. Now, we did this when we considered n to be 0, 1, 2, 3, etc., whole numbers. But this actually applies if we go beyond whole numbers. For example, if we consider n is 1/2, n is equal to minus 1. Now, if you'd like to understand all the details here, why this is the case, I'm going to refer you to 2 YouTube videos, and then I'm going to use things in there to show you how you can work this out in general. The first thing is B7 in the playlist Normal Gravity. Normal Gravity. That's the playlist that'll have in B7 the binomial expansion. Then you're going to need one more, B12, in the playlist Normal Gravity. And this is the binomial expansion with non-whole numbers. Now, I'll show you with things I developed in those videos. I'll show you how the derivation would go in general. You would write x plus delta x to the nth power in an interesting new way. And this new way is discussed in these videos. You write down x to the nth, and then you go plus, and then you put n down, counting from n, just stop right there at the n, and then divide by 1. Think of 1 as starting at the lower number 1, and then n is at the maximum. And then what you do is you have x 1 power less, and then you have delta x. Then the next one, you put n minus 1, counting backwards by 2, and then we count forward by 2, and then we have x to the n minus 2 and delta x squared. And then if you want the next one, it'd be n minus 1, n minus 2. You're counting backwards 3 times because you're going here for delta x to the third power. You can think of it that way. 1 times 2 times 3. And this would be x to the n minus 3 and delta x cubed. And on until the last one is delta x to the nth power. And here the n does not have to be a whole number. And I show you, for example, in B12, in the playlist Normal Gravity, I even take n to be pi, and I work it out, and I show you that it works using a calculator, the expansion. So once when we have this, in general now, the idea is we're going to take, like we did in this class earlier, we're going to subtract x to the n, and when we do that, this will go away because there'll be an x to the n coming from this term, and then you'll subtract the x to the n. So this will drop out, and then you're going to divide by delta x. And here, when you do that, this one is going to be n minus 1. The delta x will drop out, and all of the others will have a delta. This will have a delta x. The next one will have a delta x squared, delta x cubed, all the way up to this one. When you divide by delta x, this will have a delta x n minus 1. But the point is, after you cancel the x to the n, this is the only one that will leave something that has no delta x in it. All the other terms will have delta x, and then since we're not dividing by delta x anymore, we already did that, and when you take delta x to 0, all those terms go away, and you're left with our result. And that applies in general, where n does not have to be a whole number. Very powerful. Fascinating.